Hello guys, welcome back to our mobile computing video series. In this session, we will explore the wireless local loop, a technology that provides the last mile connectivity without the need for the traditional wired telephone infrastructure. Wired local loop, you can say it is particularly useful in the rural and the remote access areas where laying cables is expensive or impractical. We will discuss the architecture and the components of the wireless local loop, followed by an overview of the technologies used in the wireless local loop system. Okay, so this topic is crucial in understanding how wireless networks extend the connectivity beyond urban areas. By the end of this session, you will gain insights into how wireless local loop helps to bridge the digital divide. So stay tuned, take notes, and let's begin our journey. Wireless local loop architecture and components. Wireless local loop consists of several key components that enables the wireless communication between the subscribers and the service providers. The architecture includes the customer premises equipment, CPE, base station, BS, switching center, public switched telephone network, PSTN. Okay, the CPE or customer premises equipment is the subscriber's device, such as a wireless telephone or fixed wireless terminal, which connects the network. The base station acts as an intermediary between the user and the core network, handling the signal transmission and the reception. Switching center manages the call routing, authentication, and billing, ensuring the smooth network operations. WLL systems also integrate with the PSTN, allowing the users to communicate with traditional wired telephone networks. One of the main advantages of WLL is its quick deployment, making it ideal for areas where traditional landlines are impractical. It also supports various services such as voice, fax, limited internet connectivity. WLL systems can be designed using the different frequency bands, including the microwave, radio, cellular technologies, depending on the range and the capacity requirements. So, understanding the wireless local loop architecture helps in analyzing how wireless networks provide the last mile connectivity efficiently. So, technologies in the wireless local loop system. Wireless technologies, you can say the various technologies are used to implement the wireless local loop system depending on the factors such as coverage, capacity, and cost. The most common technologies include cordless system, cellular wireless local loop, microwave link, satellite based WLL. Cordless system like the DECT, digital enhanced cordless telecommunication, provide the short range wireless connectivity mainly for urban or suburban applications. Cellular WLL, it utilizes the existing mobile network infrastructure such as GSM, CDMA to deliver the fixed wireless services. This approach is cost effective as it leverages already deployed cellular network. Microwave links are used for high capacity data transmission, especially in the areas where fiber optics are not feasible. These links operate in licensed or unlicensed frequency bands, providing a balanced between the performance and the cost. Satellite based wireless local loop is ideal for externally remote locations where terrestrial networks cannot reach. While satellite wireless local loop offers wide coverage, it suffers from higher latency and operational cost. Each technology has its advantage and is chosen based on the geographical and economic needs of a region. So, understanding these technologies helps in analyzing how wireless local loop systems are deployed to provide reliable communication service. So, these conditions, or you can say this concludes our session on wireless local loop. We explored the architecture, the key components, and the different technologies to be used to implement the wireless local loop system. WLL, it plays a crucial role in providing the last mile connectivity, especially in the rural and the underserved areas. Okay. In our next video, we will discuss the third generation mobile services and their impact on mobile communication. So if you found this lesson helpful, don't forget to like, share and subscribe for more insights on mobile computing. See you in the next video.